Hello guys, hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this sorted linked list to BST problem of GFG. So this is very important DSA problem guys, uh, very important to understand and this is based on a very important approach like how we convert a linked list which is already sorted to a binary search tree. Okay guys, so first of all linked list is, I'll just explain linked list which contain node. One is the data node, one is the next node, and next node the contain the address of the next node in our linked list, and the last node contain null. Okay, this is null. Okay guys, and what is our BST? This is a node who have value has then this has value a, then it is b, and b will always be less than is equal to a, and here is a, then is will contain value c, and c always greater than or is equal to a. This is our c, this is our a. Similarly for all the children of b and c as well. Okay guys, so this is linked list and binary search tree. So now what we have to do, we are given a linked list, and we have to convert it in a reorder traversal of a binary search tree. Means we have to do a binary search tree. Okay, basically we have to convert linked list in a binary search tree. Okay guys, this is what we have to do. uh, Now we are given singly linked list, but here one thing is given to us, that the linked list is in ascending order. So we know that in a number in a particular range are always arranged according in the sequence, so that like if this is 1, this is 2, this is 3, then we put these are some sequence, and in binary search tree we know head value come in mid, then 1, and then 3. Okay, we don't need to suffer it because they are already sorted. Okay guys, now how we will do it? Now suppose for this example, first of all, this is very simple approach, just understanding, because code does not have so much important thing, just implementation, how we implement the thing. So guys, first of all, what we are doing, we are making a vector v, and insert all these linked list value in this. Why? Because we need to go, I will explain it later why we need to upload all the values in a vector. Now we are making a vector c which contain all the value, which contain the total number of nodes. Now what is our total number of nodes? 1 2 3 4 5 6 7 7. Now we call a function. Okay, this is, I am taken vector v, this is int c means count, then we are taken temporary like l node. L node is the linked list node, t node is the tree node. Okay, now temp is equal to head. Now while our temp is node is equal to null, then we just push back this particular node data in my vector, increase the count, and update temp to temp next. Then we are call a function solve 0 c minus 1 b. Now what is this solve? Solve 0 c minus 1 6 comma this v vector. Now this is the range in which we have to build our current binary tree. Now why current? Now what it will do, it will take on the mid node of this range. Like what is the mid range of 0 comma 6? What is the mid range of 0 comma 6? 0 plus 6 by 2, 0 plus 6 by 2, 6 by 2, that is 3. So we taken the node of p3, index 3, 0 1 2 3. This is node 4. So what we will do, it will take a node this, and call a function, and call a function here solve. Now 0, now we know we had taken this node, and all these value are less than or is equal to this 4. So we know these all value can only be come into left side. Okay, so we know now this is the range which come on the left side. So now it will go 0 to mid minus 1, that is 2, means 0 to 2 comma v, and it will return some tree. Now it will call a function solve till we have taken mid. So we know in the right side of a particular binary search tree all values should be greater or is equal to, and linked list is in sorted order. So we know these are the range which we can use. So means mid plus 1, that is index 4 comma till the end 6. Here in left side starting index remains same 0, in the right side right index means the ending index means 4 comma 6 and comma VO as well. I am not writing it. Now what is S0 comma 2 return? S0 comma 2 return. Now 0 comma 2 will take mid of 0 comma 2. Now what is mid of 0 comma 2? 0 plus 2 divided by 2. 0 plus 2. Okay guys, so we have to taken the mid of 0 and 2. What is mid of 0 and 2? 0 plus 2 divided by 2. 2 by 2, that is 1. So what we will, it will construct a binary tree. It will construct a binary tree which contain mid element and mid node as 1. Now what is the node index 1? 2. Current node is 2. Then it will its right will take solve mid plus 1, that is okay. Actually, light was gone and so my Wi-Fi not working. That's why some problem. Okay, guys. So now it will go mid plus one comma ending. That is 2 comma 2 and v and its left side will contain solve 0 up to mid minus 1. That is 1 minus 0. That is 2. Okay. Now what is S0 comma 0 return? What is S0 comma 0 return? As when ln is equal to r, it means we only have a single node. Okay, it means we only have a single node, so it will just return the node containing both are null, containing whose both are null, and center element is v0. Now what is v0? It is 1. Okay, so it will return 1 node contain value 1 and both are null. Okay guys, so we can update is like, so in place of s00 we can put a node, uh, I should update, change the color, and I should put a node of index 1. Okay, similarly what is s2 comma 2 return? S2 comma 2 return a single node, s2 comma 2 return a single node with index 2. Now what is index 2? What is 0 1 2? It will contain 3. It will contain 3. Okay guys, now this is 1, this is 3. So now s02 complete, so it will return this. So s02 point to this. Okay, so we can directly point to this. So we can directly say our 4 will point to this. Now s4 comma 6. Now to whom s4 comma 6 will be call. 4 comma 6 will call a function s4 comma 6 which contain 4 comma 6 which contain mid as 4 plus 6 by 2, that is 5. So what is 5? What is 5? We can see here 0 1 2 3 4 5. 0 1 2 3 4 5. 5 is 6. Index 5 element is 6 because it is 0 based indexing, so it will 6. Now it is s 4 comma 5 minus 1, that is 4 comma 4, that is 4 comma 4, and it is s 5 plus 1, that is 6 comma 6 comma 6. So what is s4 comma 4? A simple node with index 4 and all other null. So now what is 4 comma 4? 4 is 5. Element at index 4 is 5. Now element at index 6 is 7. 0 base indexing. So this is our complete binary tree. Okay, this is our complete binary tree. So like how our binary tree look like: 4 left side 2 6, then 1 3 6 5 and 7. This is our binary tree. From this 1 2 3 4 5 6, from this linked list we can make a binary tree this. So how our binary tree look like? I just make it here: 4 2 6 1 3 5 5. Okay, this is all the nodes contain the value 2 is less than 4, 6 is greater than 4, 2 1 is less than 2, 3 is greater than 2, 5 is less than 6, 7 is greater than 2. So complete binary search tree it will form. every node contain at most two elements, at most two child node. So this is the node which we make. Okay, so guys, so what we simply do, from a particular from a particular level, and at last this is the value of our h 0 comma 6, so we will just return 4, means we will just return 4, means we will just return the head of our binary tree, and this is our binary tree represented by our head. Okay, so it means for our particular node, what we are doing, we are given some range, then in some range we taken of the mid element, we are taken the mid element. Okay, put this element here, taken the range, this range come on the right side, smallest range come on the left side. Okay, because smallest range should be less than, and right range should be greater than. Okay guys, so this is how we are doing. Now there is one condition, why we store them in v. Okay, why we suppose if we have to taken, what happens again and again. Okay guys, now I think it's good. Okay guys, so what I'm saying, yeah, why we store them in a vector, suppose if we have to take on a particular element, then our linked list can be of 10 raised to the power 5 size, the maximum size given to us, 10 raised to the power 6. So for each node we have to traverse our linked list that much time, so it is approximately go to n square. Okay, now we just use on space that is given to us, we can use on space and just reduce our on square complexity of searching to o1. Okay, o1. So now our time complexity should be on, means for each node we are searching that value of that particular node in o1 time, so it will become on complexity. Okay guys, but here is one more case. If your linked list is this 1 and 2, now your c is equal to 2, so you will call solve 0 comma c minus 1, that is 0 comma 1. Now what is 0 comma 1? Take the mid element of this. What is mid element? 1 plus 0 by 2, that is 0. Now 0 is 1, 0 is 1. Oh guys, so m is equal to 0 here. I just shift to my Wi-Fi now. Okay, because electricity just came, so just a minute. Alright, so meanwhile we can understand the code. We see I explained this. Now we just turn c minus 1. Now we are taken, if my L greater than R, means we are in a range that cannot valid, because L should be less than or is equal to R for a valid range. We just return LPTR. Else while if my L is equal to R, means it is a leaf node, we just return a tree node containing VL, because L and R are and same. Okay guys. Okay, so guys, now what I want to say, if we have a node like this, if we have a node like this, like 1 comma 2, then we will call a function solve 0 comma 1, c will 2 here, so mid will be 0. Now what is 0? This is 1, and we will call a function solve from 0 to mid minus 1, that is minus 1. It will return null, so we can say it will point to null. And one function is solve 1 comma 1, mid plus 1, that is 1, and it is 1, so it is just return this 2. So this tree will look like 1 2. Okay, but what in question asked us, this is a wrong answer according to the question. It will ask us that we have to build a tree whose root node is 2 and child node is 1. Okay, this is binary tree we want. So what we can do, if we are taken mid, and if my number of nodes in a particular range is odd, is even, then I will just increment mid. So now our mid became 1, we are taken 2, then call here to solve 2 plus 1, they have 1 plus 1, that is 2 comma range 1. It will return null because L greater than r, so it will just return null. And this is l mid minus 1, 0 comma mid minus 0 comma 0, it will just return 1. So this is a valid binary tree that I need to form. Okay guys, so I just make a current new node with the index vmid. Then in current dot left, I just enter the value solve l comma mid minus 1, means l to mid minus 1, build a tree with l comma mid minus 1 as a range and transfer it in my left. Similarly with incur dot right, mid plus 1 to r, build a binary tree of mid plus 1 to r using the value of my v, and at last just return current, means this is the current binary tree head node I can make with range l comma r. And at last, when our range is complete, l is equal to 0, r is equal to c minus 1, it will just return the final answer to us. Okay guys, so here I'm submitting it. So guys, you can see all the 175 test cases pass out. Time taken is also on just. Okay guys, so I hope you all understand the approach. Today we have to face some problem because of Wi-Fi issue, but as well that don't so much bigger. So I hope you all understand the approach. Meanwhile, if you have any doubt, then first of all dry run it, and if still it is not encountered by you, then just comment out. I will try my best to explain you. Please subscribe the channel because I daily upload the problem, GFG problem of the day solution. So please subscribe, stay tuned, and like the video. Thank you for watching, guys.